Okay, here is going to be an answer to the circumcenter problem. Here's the original triangle. It's got vertices at -4, 4, 5, 6, and -1, -2. And the problem was to locate the circumcenter. And you also asked the question, is there a way to check your answer? It's a little complicated, but the answer is yes. So our goal is to find the perpendicular bisector of AB, the perpendicular bisector of AC, the equations for those lines, and then find out where those two lines intersect. The fact is that those two lines, if we found the perpendicular bisector of BC, would also intersect at the same point. But that point of intersection is going to be called the circumcenter. And if we use that as the center of a circle, with radius equal the distance from O to A, for example, we will get a circle that passes through all points A, B, and C. So here's how I calculated the perpendicular bisector of AB. That's this segment right here. I found the slope of AB, which is the change in y, 6 minus 4, over the change in x, which is 5 minus a -4, which turns out to be 2/9. I found the midpoint of that segment using the average of the x's and the average of the y's, and that's this point 1/2, 5. And then I wrote the equation of that line using point slope. Y minus 5, we're going through the midpoint, equals the slope, which is the negative reciprocal of AB, so that's -9/2, -9/2, times the quantity x minus 1/2. And if I highlight that line, there's the perpendicular bisector of AB. And I'll do a similar thing for the perpendicular bisector of AC. The slope of AC, that's this segment right here, is the change in y for that's this y coordinate right here, minus a -2 over the change in x, minus 4 minus a -1. That's 6 rather, over -3, which is -2. Then I calculated the midpoint, average of the x's, average of the y's. That's -5/2 and a +1. And there's the midpoint. And then the equation of the perpendicular bisector is y minus y sub 1, that's this one right here, equals the slope of the perpendicular, which is the negative reciprocal of the -2, the negative reciprocal of -2. Take the opposite, and then take the reciprocal as 1/2, times the quantity x minus a -5/2. Now I'm going to simplify those two equations on the whiteboard, but here's the other perpendicular bisector. And let me get this equation here so that they're on the same diagram. So here we go. New rectangular snip. Notice that the perpendicular bisectors are showing to intersect at 1, 2.75. I go into the online demo room. Let's rewrite the two equations of the perpendicular bisectors in slope-intercept form. So this one right here would be y equals, distribute the -9/2, -9/2 x plus 9/4, and then add this -5 to the right side. It will become a +5, but I'm going to change that to 4ths to 24ths. So the equation of this line right here is y equals -9/2 x plus 29/4. And then for L2, this line right here the equation is y minus 1 equals 1/2 times the quantity x plus 5/2. So I'm going to put that in slope-intercept form by distributing the 1/2. That's 1/2 x plus 5/4. But then I'm going to add the 1, so that becomes a plus 1 over here, but I'm going to change it to fourths so I can combine it with that fraction. So the equation of L2 is y equals 1/2 x plus 9/4. Now to find the point of intersection of those two lines, I want to use substitution method or the addition elimination method. I'm going to use substitution and substitute this 1/2 x plus 9/4 in for this y. So 1/2 x plus 9/4 equals -9/2 x plus 29/4. My idea to solve for x is to eliminate the fraction, so I'm going to multiply every term by 4, because that's the least common denominator of all the denominators. 4 times this first fraction gives me 2x. 4 times 9/4 gives me 9. 4 times -9/2, 2 goes into the 4 that I'm picturing up here twice. 2 times -9 is -18. And 4 times 29/4 is 29. So if I put the x's on one side, I get 20x equals, subtract 9 from both sides, x equals 1. If x equals 1, what does y equal? Put 1 in for x in either equation. I'll put it in this one right here, 1/2 x plus 9/4. So 1/2 of 1 is 1/2 plus 9/4. That's the same as 8/4. I'm sorry, 4. 2/4. 2/4 plus 9/4. Or 11/4. And as Desmos depicted it, that's the same as 2.75. So the circumcenter has these coordinates right here, 1, 2.75. Now, what does this mean? Every point on this perpendicular bisector of AC is the same distance from A as it is from C. So this distance right here is equal to this distance right here. But every point on L1 is the same distance from A as it is from B. So that means this distance, OA, has to equal this distance, OB. And that's why this is the circumcenter, because it's the same distance to all 3 of the vertices of the triangle. That's why it's a circumcenter. These are like radii. Now if I could find that distance, I could actually write the equation of the circle with that center and that radius. That's something you'll learn someday. But how could I find the distance from O to B, for example? I could use the distance formula. D equals the square root of the change in x would be 5 minus 1, or let me go to Desmos and show you. Here's the circumcenter calculation. Here's the circumscribed circle calculation. Distance is 5 minus 1 squared. That's 5 minus 1, the quantity squared, plus 6 minus 2.75. There's the distance formula. And this is the equation of a circle that has this center and this radius of D. x minus 1, the quantity squared, plus y minus 2.75, the quantity squared, equals d squared. That's the equation of a circle. And if I highlight that circle, boom, there it is. It's going through all 3 points of the triangle. So that's how you could check your work on Desmos, but you would have to understand how to write this equation and how to determine d, which you should know how to do because you're familiar with the distance formula. Okay, but the answer to your problem was this right here, 1 comma 2.75. This distance was the square root of 5 minus 1 squared plus y was 6 minus 2.75, the quantity squared. And the equation of the circle, once we know what that distance is x minus the x coordinate of the center plus y minus the y coordinate of the center equals the distance squared, or the radius squared. So in the diagram here I called D with I named D with the letter R for radius. But that circle went through all 3 of these points. That's why O is called the circumcenter. There you go.